Hello YouTube viewers, welcome to my Expo Explained videos. I do apologize because I'm not having the time of making a presentation, although I may have to travel again. So I'm hoping that you have seen HrimTron Energy company, and this is just an explanation of what we had and what we talked about. Now this company is making ORC, Organic Rankine Cycle. Basically it's almost like steam cycle, but instead of water being the main fluid, you generally use some sort of hydrocarbon organic decimal point like isobutane or propane or things of this nature. Why? Well, here's the deal. Many people have very underwhelming understanding of how power hungry steam cycle is, meaning can you make basically a steam cycle that is efficient, let's say 35% or maybe even 40% efficient? Can you do that? Of course you can do that, but what's the penalty is it requires bonkers high T delta, meaning when you are burning your coal you have to almost turn them into dust, have massive blowers blowing through it, and then you have to just like whoosh into it, and that temperature could be as high as 1600 degree Celsius. The water itself, like that's the fire, the wall around it could be very hot, and the water that is flowing under pressure could be very high, as high as 1000, or many designs are even higher than that. So while steam cycle is really amazing, it is hungry for T delta. Without T delta it's useless, meaning if you want to like, oh, why don't we use heat from data center to run turbines, you can, but you can't do that with steam. So that's the whole problem with steam cycle. Really good, really efficient, robust GG technology, but it requires bonkers high temperature delta, like hundreds of degrees Celsius, like 700, 800, or maybe even 1000, or like 1200 kind of degrees Celsius. So that creates a limit where if you have low grade heat, let's say you are doing metal processing scenario, you have so much waste heat that is hot but not that hot. In that scenario, ORC becomes your saving grace. So this sort of technology, ORC, allows you to recover waste heat. That's the whole motto of this company. Basically recover clean energy from waste heat. Now, where could we have that kind of waste heat? Well, steel plants, where you see the roll steel plant, they require a lot of cooling. So again, basically they are trying to cool down very molten metal into useful metal. So that's a very severe amount of energy. But then why don't we recover it? It's not high enough temperature. Is it hot enough, like 300 400 degrees Celsius? Of course. Is it hot enough to run a steam cycle? No. So using ORC makes sense. Aluminum foundries, ceramics, glass, all of those things, basically wherever you have something molten and you are generally trying to cool it. And even in other scenarios like concentrated solar, you can make this work. So having ORC is almost like a add-on to your industrial infrastructure, so you can improve its efficiency. So that's the core essence of it. Now, let me be very clear. I think there was a bit of a miscommunication when I did the recording with the basically member of the team. He was talking about like you can get energy as low as like half degree or like almost 1 degree Celsius. I don't think that he was talking about T delta between when I was saying T delta, I was meaning between what's your hot temperature and what is your coolant temperature. Like in case of coal power plant, it will be like 1600 degrees Celsius is the hot end, and the cold would be ambient, let's say 50 or 60 degrees Celsius. So that's what I was talking about. I think he misunderstood it with what was the T delta for the heat exchanger inside, like one component. So, and again, can we have organic Rankine cycle running on very low T deltas? Yes, people have been successfully running it, but it drops in efficiency and it is not very efficient. Like steam turbines, you are lucky if you are looking at 35 to 45% efficiency, that zone. When you are talking about organic Rankine cycle, it can drop as low as 10% if the T delta is not high enough. It will work. That's the good part. Bad part, it will be very inefficient. So don't expect to just put like solar water heater on your roof and run ORC. Can ORC run? Of course. It will just not produce enough power. So so I'm doubtful of his claim of like using basically data center heat, because can data center heat have enough T delta? It should be, because CPUs are not designed to run cool. They're designed to not overheat, as in like you can easily keep it at 50 degrees Celsius. So assuming you are running a normal chiller, and the chiller can easily have outside temperature, as in like the reject temperature 60-70 degrees Celsius. Now, if you are in a European environment where ambient temperature is lower, it could work. I could see that working with decent enough efficiency. But in India, so I just wanted to clarify. I think there was a bit of a miscommunication. So what's their special sauce? Their special sauce is basically the high-speed turbine that they have designed. Basically, you have to understand, whenever you're talking about something spinning, you generally have a lot of vectors. For example, if you're talking about motor generator MGU, you have voltage, you have current. Now both are limited. You can't increase current too much because conductor will melt. You can't increase voltage too much because the insulation will fail. But if you have maxed out, like you can't increase the voltage, you can't increase the current, you have RPM to increase the RPM and get more power from the same size. And again, it's a normal thing we do in almost everything. For example, your household electricity could have been 50 hertz or 60 hertz, but in airlines, because again it's an ancient technology and they wanted to have very small but very powerful motor and cooling, blowers, fan, everything, they upgraded frequency to 400 hertz. And again, same thing can be done in CNC spindles. They could be running as high as 2000 hertz. Same with your electric motor. Same goes with power turbine also. You can shrink the mechanical turbine and the motor generator unit and still get bonkers amount of power. So the target is inside a 40 foot shipping container, maybe even as small as 20-foot shipping container, they should be able to ship you 25 kilowatt hour system. And again, that's the whole point. The heat exchanger itself is not huge. It's a dimpled plate heat exchanger. You need two of them. You need a one pressurizer pump. Like again, that's the same thing used in coal power plant also. You do not flow water normally. You pressurize the water like it. So it does the job, so to say. So that, and then you have a turbine. Turbine is also called expander. So that sort of RPM, like very high, thousands of RPM would be utilized. Now this is the one of the few good companies where they have actual number what they are talking about, as in like localized cost of energy. They are thinking about like 3 rupees per kilowatt hour, and the payback is generally 3 to 4 years. Now, can that actually be real? Very easily, especially if you have high temperature heat, because at high temperature heat you can increase your recovery from 10% to 30-35%. At that point in time, it's like not doing it is wasting money. So this is a really cool, clever technology. This is like genuinely clever. It's like, hey, ORC does exist. What can we do to improve ORC so it becomes far more adaptable? Because there are many industry, like whole country has industry, and India wants to become industrial power. So yeah, we have a lot of industry. So why not use that, recover that? Even like 10-20% of recovered energy, that's a lot. That's a lot, because you are talking about like megawatt hours, hundreds of megawatt hour. So it does translate into a massive gain. And I did talk about like, what if I want to create a silicon-free technology system? And I'm like, why? Well, here's the deal. Certain things you do not want silicon integration into it, and again, certain places can't have it. For example, in India is like really in the top most of the countries. There are 200 countries. Just because we compare to like the best of the best, it feels like India is not that great. Yeah, it is. Like try to being in Sudan, and you'll be like, me good. So fundamentally, what if you are in a landlocked country in middle of Africa or some other places? There are many countries that are like that. They do not have good enough currency to just import inverters. We have very strong currency, so we can just like, hey, Israel, my man, give us a lot of solar inverters. Yes, we did that for one of the massive solar farm projects. So we can just buy it. And again, we are working very hard to make sure that we can make silicon solar cells. Inverters are far away, but at least cells can be manufactured. So what if you want to create power grid without creating silicon dependency, where it's like some other can sanction you, or might not just sell you or overcharge you or have control over your grid? So this sort of ORC makes sense, because again, glass, mirrors, these things are ancient technology. Everyone, including middle of Africa, knows how to do this. So where you can have concentrated heat and ORC will give you same efficiency, like and again, we are looking at 50 degrees Celsius, you are going to get 30% efficient. Actually, that will be higher than what you will get from a normal basic solar panel. Single junction solar panels are 20-25% efficient at high temperatures. This does not care about high temperatures, so it will be more efficient, and you can make the hot very hot, and it also has spin mass inertia. But I did specify, like if you have high speed rotor, you can't have grid. Grid requires low, massive low RPM, like 60 hertz, 70 hertz. That only requires 1500 RPM to 3000 RPM. You're generally not going higher than that. So can it be done? They said yes. If you scale the system up, then you can have those sort of like, let's just say I'm trying to make a solar farm of 50 megawatt or 100 megawatt. I can have a turbine that is grid synchronous. And not to mention, high temperature also allows you to have the benefit of storing that heat. It's doable. Now again, storing electricity in batteries, it's very efficient in round trip efficiency wise. Storing energy in thermal batteries, it's very efficient in terms of cost. So again, I can ask any Tom, Dick and Harry, like, can you figure out how to make a quality graphite? Not that difficult. I can't ask many people to make a a normal lithium ion battery and associated inverters and keep making them every few years. So this is a really cool technology for not only for energy recovery, but as an energy source in certain places. If you want to have like a resilience, grid inertia, and like complete independence, whereas like I do not care what happens to the world, we good, we got this, and it will be good enough. Like it will be decent enough where it's like you're gonna have enough power, you can have inertia, so you can mount more. Oh, by the way, most low-cost solar inverters require grid inertia to be there, otherwise they won't work. And if you are like going into grid forming inverters, look into the cost. So this is a really clever utilization of organic Rankine cycle, fine-tuning the generator so it becomes smaller and cheapable. And the fact they also thought of it, it's like, imagine if you have a plant, right? Steel plant or aluminum plant, you may not be working at the same fixed load all the time. So having one massive unit which you down throttle is not good for efficiency. So the idea is they're gonna have smaller unit modules, 25 kilowatt, 4 units. So you can throttle it effectively. So these are very good and clever, and I'm genuinely impressed by the compactness. The whole machine is surprisingly compact, meaning I can actually see this being slowly becoming a thing that every steel plant, cement plant, aluminum plant, they just have it. It's like, it's a thing, we just do it to reduce our running cost. And again, if ROI can be done in like 3 to 4 years and the machine lasts even as short lifespan as like 10 years, which again for industrial equipment 10 years is acceptable, fine. It's good. Lower energy consumption for the industry, good. Reducing pollution for requiring more power consumption, good. Maybe even direct solar thermal energy production, again in certain scenarios it would be good, but again only at large section where you have grid inertia. If you don't have grid inertia and you're gonna buy this high voltage inverter system, sorry, high frequency inverter system, might as well just buy solar panel. So it is very clever, very unique, and I'm very happy that this sort of unique things is finally happening in India, and I'm getting to cover it. So this was my presentation on it. I hope you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me disappointment. Please leave a comment because I do try to reply to all of them. And thanks for watching.